In this video, I'll briefly go over each level available in the VAT folder of the content examples for my GameTools Blender extension. Each folder includes a source folder containing the blend file, the mesh, an XML report, and textures. The blend file is especially useful as it lets you see the exact settings used for the bake and how the VAT bake tool was configured to achieve the demonstrated result. Alright, so the first folder showcases a closed simulation baked into vertex animation textures. This was featured in a previous video, so I won't go into much detail here. There's a material that demonstrates how to place the baked simulation, and a second material that shows how to make it loop. The next folder demonstrates the continuous packing mode. In cases of data overflow or underflow, meaning there are more or fewer vertices to bake than the maximum or enforced texture width, this method stores the data one frame after the other instead of stacking them vertically. This can pack data more efficiently in the texture, especially in scenarios where overflow would otherwise waste a lot of pixels. For example, if you have, say, 2049 vertices and a texture width limit of 2048, you double the texture height just for one extra vertex, which is very inefficient. And this method avoids that, but it's more complex to sample, doesn't support frame interpolation, and may suffer from precision issues with high frame counts. As such, it's an experimental feature and most of the time you probably won't need it, but it's worth experimenting with. The next folder demonstrates baking every nth frame instead of every frame, resulting in much smaller textures. This reduces animation fidelity, and you'll need to adjust the playback speed accordingly. The following example shows how to bake multiple objects at once. For the most part, this just works, though there are some edge cases explained in the 5th video, so I won't go over it again. The shader setup remains unchanged. Here the texture width was limited to 2K, resulting in data overflow. The data spans multiple rows, so the material needs to account for that. The frame height feature must be enabled and the correct value, reported by the bake tool, must be specified. This setup disables pixel interpolation for frame blending, but interpolation can still be done manually by sampling the texture one frame ahead and lerping between values. Next, I'll probably make a dedicated video about this example at some point as it's quite interesting. Basically, I'm using Niagara to build a state machine that plays specific VAT clips based on the particle state. It's not too complex, the Niagara system itself is fairly simple, and so is the shader, but it's beyond the scope of this video. This example demonstrates baking the actual vertex positions rather than their offsets from the reference frame. This isn't very useful in Unreal Engine, since vertex positions are calculated anyway, so you might as well just store and apply the offsets. But in other engines or in a custom vertex shader pipeline, you could apply the positions directly from the texture. In this example, again, I simply subtract the reference position to convert the stored position back into an offset, so it's redundant and useless. Next, this example shows the recommended approach for baking and sampling VATs, as covered in previous videos. The normal texture is remapped to the 0-1 range so it can be stored in RGBA8 format, reducing memory usage. It thus needs to be remapped back to its original range using a material function, nothing fancy. Now the same can be done for the offset texture, which is quite interesting. This introduces some precision loss, so the animation may lose a bit of fidelity, but in some cases the difference is hardly noticeable, as you can see. It looks fine and cuts the offset texture size in half. You just need to use the appropriate material function and feed it the offset and range values reported by the bake tool. Next, this example demonstrates the retargeting feature, which lets you bake the vertex animation of a high-resolution mesh onto a low-resolution one. It's an approximation and may not work well for all meshes, as explained in a previous video. It's still something that could be very useful for LODs and such. Next, this example demonstrates baking a mesh sequence. In Blender, I duplicated and moved a cube several times and the full sequence was baked into a vertex animation texture. This is further illustrated in the following example, which shows how to create a stylized VFX. I covered this in a previous video, so I'll move on. Finally, the last example is similar to the multi-rows case, where the texture width limit causes data overflow. However, this layout handles row spanning differently and supports pixel interpolation for frame blending. Sampling the VAT textures then comes with a few caveats, but these handy functions takes care of them. And that's pretty much it for the content examples related to vertex animation textures.